All right, so today we're going to talk about integration by parts um, and how the rule u times dv is equal to u times v minus the integral of v du. All right, so we're going to talk about how these functions were derived and how this equation is derived and how this relates back to um, a reversal per se of product rule in derivatives. Okay. First things first, we know that if we take the derivative of two different functions, uh, v of x, and when I say different functions, I'm talking about, for example, u of x will be a polynomial and v of x will be something like a trigonometric function or a logarithmic functions or an exponential function. Okay. So if we take the derivative of two functions that are multiplied together, we will get the derivative of the first function or whichever one, it doesn't really matter, multiplied by the second function, and that's plus the derivative of the other function multiplied by the other function. Okay. Now we have this equation, and let's say we want to take the integral of the whole equation. Now, taking the integral of the whole equation will not do anything because we're applying it to both sides. Okay. So now, if we take the integral of a derivative, we know that we're just gonna be left with the function that's inside the derivative. Okay. Now, when we take a function or an integral of a function of this expression, which has one derivative and one function that is just normal, we're going to get the um, derivative of the function as just a constant multiplied by the integral of the function that is not um, derived. Okay. And that's added to, again, applying the same rule, we're going to be left with the constant of the function that is a derivative multiplied by the integral of the function that is not a derivative. Okay. Now that we have that, how did we actually come up with this? All right, so we're going to do a little bit of rearranging by subtracting this function, this side, and um, oh, sorry. Um, let's see. We're going to be left with u dv, which is this. We're going to treat this as dv and this as du. Okay. Now we're just going to subtract this function or this expression to this side. So now we're going to left, and actually let's put this equation on this side. Okay. So now we're going to be left with u, the function of x, multiplied by v, sorry, v of x dx, and that's equal to this. u of x, v of x, plus, um, or sorry, subtracted by v of x, u of x times dx. Okay, now we're just going to treat this as this will be dv and this will be du. And then since these will be just regular constants in the end, we can just plug it back in. Plug it back in. Okay. Let's move down a little bit. So we're going to be left with the derivative of u dv. Remember, this will be dv. And that's equal to u, sorry, v minus, and we're going to plug that back in, v du. This is the okay. Now we're left with this equation, which is what we talked about right up top, right here. Now, how are we going to choose which one is going to be u? Okay, u is going to be very important here since this is our initial equation, the equation that we're going to be looking for, or that we're going to be given with, and there's something called an acronym, something called LIPET, LIPET, that stands for logarithmic inverse trigonometric function. This is a polynomial function. This will be an exponential function. Trigonometric function, a regular trigonometric function. Okay. Now, like it. So how are we going to use this? We're going to choose u based on this ranking right here. U will be the function that first shows up in this ranking. So, for example, if you're given, let's say, the integral of x squared sine x dx, u will be x squared since u is higher on the bracket than since x squared is higher in the bracket than sine x. Sine x dx will then be our dv. This will be your u. Okay. Now, why? Why? This has something to do with how complex it is to take a derivative versus an integral of a function. So u, we will have to derive u here, right? We will have to derive u. And v, we'll have to integrate v. Think about this. If u is x squared, and let's say, or if we have x squared times, let's say, a log of x, and that's an integral dx. Okay. And so for this, u will be log of x. That'll be our u. And this will be our dv. Now think about this for a sec. Taking the integral of x squared is just as simple as, or is as simple or hard as x to the n plus 1 over n plus 1, where our n is equal to 2 in this case, versus taking the derivative of log of x, which we know as just 1 over x. It's as simple as that. Now, I'm going to go through an example in the next video, so stay tuned for that.